Hello again. So, now let's get some practice with this modular addition that we have established. So, this asks us to state whether each of the following is true or false. So, let's start with part A. 73 plus 89 is the same as 3 plus 9 mod 10. Well, mod 10 is super easy to work with because you just look at the ones digit. So, it is absolutely true that 73 is congruent to 3 mod 10. You can confirm this by doing division. Or think of, 7 times 10 is 70 plus 3, your remainder would be 73. And it is also absolutely true that 89 is congruent with 9 mod 10. So, because these facts are true, the addition holds. We can think of 73 as like A1, 89 as B1, and 3 as A2, and 9 as B2. So yes, this is true. And, we can just also derive from this like a new congruent statement from these facts. For instance, like if you just add up the values together, 73 and 89, 73 and 89 is 162. That is congruent to, 3 plus 9 is 12, and 12 mod 10 is just 2. So 2 mod 10. So we can find some very easy congruences with that information. Part B. Well, we have 93 minus 47. So 93 mod 9 has is that the same as 3? Well, yeah, because 9 times 10 is 90 plus 3 is the remainder. So we have that 93 is congruent with 3 mod 9. Okay, well, how about negative 47? Well, if we think of it in terms of like multiplying by 9, I'm going to write this out as negative 47 equals 9 times, that would be a negative 5. The negative 5 would get me negative 45, and then my remainder would have to be a negative 2. So yes, it is absolutely true that negative 47 is equivalent to negative 2 mod 9. And therefore, yes, it is true that this congruence holds. And from that, we can establish some nice facts, like the fact that if we do 93 minus 47, we get 46, and that must be congruent to 3 minus 2 is 1 mod 9. So we get some, easy to find congruences again. Now, let's look. We have 403 plus 397. Is that congruent to 3 plus 7 mod 8? So let's check. Now, 440 is a multiple of 8. So if we do 8 times 50, we get 400. So 403 is the same as 8 times 50 plus a remainder of 3. Whoa. So yes, 403 is definitely congruent to 3 mod 8. Next, we have to establish the 397. Okay, well, again, 397 is pretty close to 400. 397 is pretty close to 400, but not quite there. So I would have to do 8 times 49. 8 times 49 being 392. But to get to 397, I would have to add 5 to that as my remainder. So 397 is congruent to 5 mod 8. But this wants it to be congruent to 7 mod 8. So it ends up that this is false. This is not true. Because this 7 needs to be a 5 instead. Continuing on, we have some increasingly complex problems. But let's think this out. So 1214 mod 7 is at a 3. Let's just do 7 divided with 1214. 7 goes into 12 once as 7. Then to get to 12, we would have to add 5 to that. So that would be 5, drop the 1 down. Now 7 into 51, well, that would be 749. And 51 minus 49, well, that's 2. Drop down for 24. That would go in 3 times for 21, and we would have 3 as our remainder. So yes, 1214 is the same as 3 mod 7. Now we have to check 1591. So 7 divided with 1591. It goes into 15 twice, so 14 minus 15 is 1. Drop the 9. Goes in twice again, so 14 minus 9 is a 5. We got 51, which would go in 7 times, so 49. 49 minus 51 is 2. So yes, our remainder is 2. So the congruence in this case does hold. We have a true statement. And from there, if we wanted to, we could establish some easy congruences by combining these two. We have 2805 would be congruent to 5 mod 7. Alright, now for the next part. 134 plus 453 minus 217. Is that the same as 2 plus 3 minus 1 mod 12? Well, we have a lot to work with. If we can find one false statement, then it's going to ruin the whole thing. So let's just start with the first term, 134. Is that the same as 2? Mod 12. So let's take 12 divided with 134. Well, it goes in once, it comes 2, minus, We get that that becomes a 1, drop the 4. It goes in once again. We have 12 minus, we got remainder 2. So that holds. 134 does match with 2. Okay, how about, let me erase some of the old work. What if we have 453, mod 12? So 12 divided with 453. Well, 12 goes in to 453 37 times. And 37 times 12 is 444. Subtracting these two, 453 minus 444, we get 9. Now a 9 doesn't show up anywhere on here, so we can immediately conclude that this must be false. Then, for the last one, sometimes it's easier just to throw everything together, add it all up. So 2,372 plus 971 minus 1,549. That is 1,794. Is that congruent to? Well, 7 plus 3 minus 9, 1. Is that congruent to 1 mod 11? Let's check. 11 divided by 1,794. It would go into 17 once. 11 minus, or 17 minus 11 is 6. Drop the 9. Goes into 69 6 times. So we have 66. 69 minus 66 is 3. Drop the 4. Goes into 34 3 times with 33. And indeed, we have a leftover 1, so we have a remainder of 1. So yes, it is true that this congruence holds. And so this shows you that sometimes it's easier just to combine everything together. Sometimes it's easier to do them separately. It depends on the situation. But it just shows you the flexibility we have when doing these sorts of modular arithmetic problems.